Welcome to the solutions to the AP Physics Equilibrium problem set, problems 1 and 2. We get started in this new unit in equilibrium with a few conceptual questions. Let's address two of them right here. Number one, if a car moves with a constant acceleration, can you conclude that there are no forces acting on it? Well, it may be obvious to you based on our previous unit in Newton's laws of motion that if the car is accelerating, it has a constant acceleration, Newton's second law says that there has to be a net force in the same direction as that acceleration and proportional to that acceleration. So if we draw the forces on this accelerating car, so we'll say that the car is accelerating in that direction, the free body diagram, of course, would be the weight down, the normal force up. There has to be a force forward, which is supplied by the tires on the road. And of course, we know that we have kinetic friction backward. What's important to note here is that in order for the car to be having a constant acceleration, that the forward force F has to be greater than the kinetic friction backward in order for that to happen. So can you conclude that there are no forces acting on it? Obviously not. In number 2, let's take a look. We have a space explorer moving through space far away from any planet or star. He notices a large rock taken as a specimen from an alien planet floating around in the cabin of the ship. Should he push it gently or kick it towards the storage compartment, and why? Well, you've probably seen pictures of astronauts inside the cabin of the ship, and all they have is pretty much a loose spacesuit on. They don't have boots and gloves and helmets and all that kind of stuff because the cabin is pressurized and they don't need to have all that stuff on because they have a supply of oxygen, etc. But I'm going to show it here with this space rock and this boot that, again, this is simply a Newton's third law question that if, and pretend that this boot is the bare foot of the astronaut, makes it even worse, that if the astronaut were to kick and apply a big force to the rock, Newton's third law says that for every action, there's an equal and opposite reaction. So there would be a force of the rock back on the foot. And that force would be equal and opposite. So the harder you kick the rock, the more force the rock would exert back on your foot. And this would be a painful experience. Now what people get caught up in here is the fact that out in outer space, that things are weightless. And while that may be true, this rock would have no weight, so its weight would be equal to 0. Its mass is not equal to 0. So it still has, it's still made of a certain amount of matter, and so it still has non-zero mass even though it's weightless. So if you apply a force on it, F equals ma, then there's going to be a force back on you that's equal and opposite according to Newton's third law. Not advisable to kick the rock. You should gently push it. All right, there's the explanation and answers to the first two problems. We'll be looking at problems 3, 4, and 5 in class tomorrow.